I'll kick us off with just, as the video sort of mentioned, right, we're working on trying to catalyze this net zero carbon retrofit revolution. I think many of you have likely heard of Energy Sprong, and our effort is definitely based on and inspired by Energy Sprong. So this whole kind of movement started about 5 years ago, when a group of us got together in Washington, D.C., and we had, Ron and Jasper from Energy Sprong come out and give this really inspirational presentation on what they are doing over in Europe with these standardized retrofit systems. And everyone in the room agreed, like, we just need to stop being incremental and eking out a little bit of efficiency here and there and just take these things all the way to zero. So fast forward 5 years, and we've been able to raise some resources to start a program to launch net zero carbon retrofits for the affordable housing market here in California, which is where Amy and I are based. So just want to give a kind of quick shout out to our team. We're sort of a big group. As I mentioned, we were awarded a grant.
To get all the cars to go back to self-driving. It's not gonna fucking happen.
Hey Martha, I'm gonna mute everybody, and you're gonna have to unmute yourself, okay?
Okay, sure.
Yeah.
So as I was mentioning, we were awarded a grant from the California Energy Commission, and our team consists of the Association for Energy Affordability, who's really helping us kind of implement a series of pilots that we have underway, which is what Amy's going to talk about later. Energy Sprong obviously has been working with us from the get-go, but we also have San Francisco Department of Environment, UC Davis, Integral Group, and David Baker doing the engineering and design. California Housing Partnership Corporation is helping us with the finance and sort of regulatory and policy aspects of the project. Prospect Silicon Valley is also helping us with kind of sourcing emerging technologies and different kind of startup partners. And then Stone Energy Associates is also working with us on some of the policy and financing elements. And then, of course, Passive House Institute US has worked very closely with us on developing the standards, the retrofit standards and guidelines that we're developing for this form of construction. Just to kind of tee up exactly what are we doing, that video was really nice, but what does that mean? What are the brass tacks of this? We're not going to try and reinvent the wheel. This is basically the sort of market intervention model that Energy Sprong recommends, but I'd also argue that if you look at most corporations, they are doing some element of these 4 activities. They have a pipeline for generating business, that's the demand side. They are producing a product and organizing their value chain to deliver that product. They are aware of sort of the policy environment in which they work and when it's conducive to their business models and it's not, and they work to influence it. Some of us might not always agree with their methods in doing so. And then there's a finance element. How do you make your product accessible and affordable to a customer? And I think, we've seen finance streamlined and package financing be a part of everything from, buying a car. You can basically walk onto a parking lot of new cars and walk away in an hour or 2 with a new car, right? And you never even opened your wallet. So all of these elements are a part of creating a market transformation and making it easier for for consumers to basically adopt what we're recommending, right? And that's these net zero carbon retrofits. So we are acting as an organizing entity and trying to basically go to different geographies across the US to enable this model. So Amy and I basically today are going to cover 2 main areas of this wheel: the finance section, which I'll talk about here briefly, and then Amy will dig into the supply side, which I think is where most of you will, the wheels will start to turn for you and ideas will emerge. So the first thing that we have to do, like I said, is to make this something that is consumable, right, by designing a financing model that works for building owners. As I mentioned, we're working with the affordable housing market segment. A really big barrier for them has been solving the split incentive issue. And we're very fortunate that here in the state of California, we have a mechanism called the California Utility Allowance Calculator that allows for owners to kind of recalibrate rents based on tenant energy savings and capture those rents and sew them into the project. And so the idea is that when we actually underwrite a much deeper level of savings and combine that with incentives, we can start to really get these projects to pencil and to enable projects to move forward. One other important thing to note is it's really important, obviously, to make sure that these things not only improve tenants' quality of life, but that tenants are also parties to the benefits of the savings. And so that's been a part of the financing solution that we're looking into. Now, kind of underscoring all that, or kind of the backbone behind the financing model, is ensuring the savings. And again, emulating the construct that the Europeans developed with Energy Sprong, is they divided performance risk into two components. There's kind of system risk of the actual equipment and performance of the building, but then there's behavioral risk. And so there's kind of two sets of contracts that the Energy Sprong model uses. It's a performance contract with ongoing maintenance and monitoring that what we're calling solution provider delivers to the owner. But then the owner also enters into a contract with the tenant where, similar to your cell phone plan, where you have a certain number of minutes every month, they have an energy budget. And if they exceed that energy budget, then they might be charged a little bit additionally by their utility for exceeding that budget. But if they stay within their budget, they do not incur any additional costs. And so the instrumentation and that monitoring equipment all goes into this integrated mechanical pod, which you're going to hear about later. I'm sure many of you have been talking, I guess, about the magic box. But that all kind of, most of it resides in that set of integrated systems and allows for the ongoing monitoring that enables this sort of performance model to work, and therefore creates a stream of cash flows that are guaranteed and can be captured by the owner. So these are the major elements of the finance side, and what we're still kind of in the weeds on kind of putting together. What that looks like, from an underwriting standpoint of kind of the different elements of an owner's capital stack. But I think this kind of gives you a sense of what we're working on the financing side. I'm going to hand it over to Amy now. We could have shared a lot more, but we want to keep it to 15 minutes. So I will stop talking and let Amy get into the technical details.
Cool, thanks, Martha. And hi, everyone. I'm Amy Egerter with RMI. And so I'm going to walk through more specifically some of our technical findings from the California grant that we've been working on for the past year or so now. But Martha was kind of talking about a one-size-fits-all financing program to make this program scale. And we really wanted to think about what are the variations of a retrofit package that we could scale quickly and easily across, the most prevalent building types in the state of California. Multifamily building types specifically. So we did this typology study late last year on the 2.9 million existing occupied units, multifamily units in California, and tried to figure out, okay, what are the most common multifamily building types we could use to scale this thing. So we identified 3 different building types that would be a good starting place for us to work in. 82% of multifamily buildings in California are less than 3 stories. So low-rise multifamily is really the most prevalent typology you're going to see in California. Some kind of a low-rise stick frame building. Within that 82%, these 3 types are kind of the most popular or most frequently seen. So there's the townhouse, which is almost looks like single family, 1 to 2 story. 1 to 4 units kind of pushed together in the one building. And then there's a garden style, which is maybe 2 to 3 stories, but still exterior circulation, walk up units. And then the third would be kind of a bigger 3-story-ish loaded corridor prototype where you have the interior circulation, whether or not it's conditioned is, to be, it's, sometimes conditioned, sometimes not, depending on where you are in California. But so this is really our starting point for, like, if we really want to hit scale with what we design, we need to design for these 3 building types. Looking a little bit deeper into, like, besides the geometry and like the physical characteristics of the buildings, what kind of systems do they have? We're able to get a lot of useful data from our partner, Association for Energy Affordability. They run the low income weatherization program in the state of California, so they have a lot of insight into what kind of systems exist in these kinds of buildings. The smaller townhouse buildings, a lot of natural gas, gravity well furnaces, sometimes central forced air furnace, a ducted configuration. In the Bay Area and in like coastal Los Angeles, you very frequently don't see any cooling systems, or you'll have kind of like one of those rooftop systems that you see on the townhouse image on the roof. And then domestic hot water for the smaller buildings is almost always in the unit, almost always natural gas as well. And then as you get bigger, there are some central configurations. Garden style, the systems look pretty similar to townhouse just due to the size and the scale. And then for loaded corridor, as the buildings get bigger, there's some frequency of central steam and hydronic boilers with a radiator, but it's less common in California than what you might see in the East Coast or something like that. So next slide. So then, you kind of got the sense from this from our video, but trying to think within those 3 typologies, how can we make these technologies that are prefabricated, reduce on-site labor, reduce tenant disruption, and kind of form an all-in-one package so you can deploy. So there's the insulated facade panels in the Netherlands. They include windows and doors and are kind of hung on the existing building. So that's kind of the hypothesis that we're working with. More on that in a second. And then also insulated roofing panels that could integrate solar. And then kind of this magic box idea, we've been calling it an HVAC pod that can provide heating, cooling, and ventilation in one system. So it would have one heat pump that can do kind of all 3 functions, and then an ERV. And then electrification of appliances is also key. So yeah, I think, the target of this is just improve living condition, reduce energy expenditure, new construction jobs, and also reducing on-site labor. Not sure what that arrow is about. Go to the next slide.
I feel like somebody's whiteboarding.
Someone's annotating.
Yeah.
So anyway, going into, we have our building types. We know what we want to develop. We know kind of what the end state should be. And then we kind of set out on this energy modeling, engineering exercise to really figure out what those packages look like for those typologies. So we had, for the energy modeling, we had a preliminary set of specifications that were set using the FIAS guidelines. So we knew kind of what energy targets and load targets we needed to work towards with our packages. And then we ran a parametric analysis using Energy Plus based on typical values we were seeing from manufacturers for the roof panel, wall panel, testing double or triple pane windows, etc. We also tested this in 6 different climate zones in California, ranging from, Tahoe area in the cold mountainy areas down to the desert in southeastern California. We then, RDH Building Science is a partner on a grant that we have to develop facade panels, and they assessed kind of what was structurally feasible for a facade panel, given the types of buildings we're looking at. So that turned out to be pretty limiting, but I'll talk about that on the next slide. And then we kind of consolidated that energy modeling, those energy modeling results for the different climate zones, what products were available from manufacturers, and then also what the structural criteria were dictating we could actually put on top of stick frame buildings in such a seismically active state. And we came up with the final retrofit packages. And so this slide illustrates, basically summarizes all of our major findings from this whole process. So right now, I'll just walk through kind of the typical flow of the decision tree. Right now, if you have a low-rise building, realize it is developing a product that can cover your building. If not, it's coming, but we don't have it yet. And so then the next question you really need to ask yourself is the building in need of a seismic retrofit? In working with RDH's structural engineers and looking at the California seismic code, we're finding that these buildings, because they're so lightweight, can only really support an additional 4 to 5 pounds per square foot of a facade panel. And just for context, the panels that were developed in Energy Sprong were about 8 pounds per square foot, around there. So we needed to get to about half that. And so there's some implications for what that means of how deep you can go on the facade, given that limitation. So just walking down the tree a little bit more, if you don't need a seismic retrofit, it then is just the question of, does your building have existing insulation in the wall or roof? If it does, our solution for that kind of a building, so it doesn't need a seismic retrofit, it already has existing insulation. The retrofit package that we would recommend is an R30 roof panel, triple pane windows, some air sealing, and then different solar heating coefficients for the building depending on what climate zone you're in. And so that's one avenue. If you don't have existing insulation and you also don't need a seismic retrofit, we were seeing the threshold of that 4 pounds per square foot really coming in at like an R8 to an R12-ish panel. We're still investigating depending on what kind of insulation you use and what kind of product. But an R8, R12 is kind of the threshold for that 4 pounds per square foot that you can get to without triggering a seismic or structural upgrade. Again, triple pane windows in some climates, double pane windows in others. And then you can get much better air sealing, we think, because you're rewrapping the whole building and with panels and a roof and whatnot. Now, if your building does need a seismic retrofit, you can go full FIAS on this. So whether or not your building has existing insulation still matters, but your panel will need to provide some amount of seismic structural support, strengthening the building. But you can also get much higher levels of insulation here. And again, targeting 1 ACH50, and then because the walls are much more beefed up, just sticking to a double pane window, we think will be most cost effective. So those are the 4 major options we're working on right now. We're working with a couple of panel manufacturers to produce these types of panels and go through that R&D process. And then we have some other demonstration sites where we demonstrate the roof only package. Can go to the next slide. So mechanical systems are a whole other thing that we're working on, and we also have a follow-on grant to work on this, the development of kind of an all-in-one system. But in the meantime, so there's kind of this end state of using a product like the Genius by System Air, which has an air-to-water heat pump that provides space heating and cooling, and domestic hot water also has an ERV in there, I believe, and controls. So this is kind of the end state of what we want to get to. Energy Sprong has used this product and others in their retrofits. And we have one unit that we're testing at UC Davis in their lab right now. But because none of those products are currently available or made to be sold in the US, we're kind of focusing on demonstrating quote unquote transition technologies that can combine 2 or more functionalities, so they can provide heating and hot water, or space heating and cooling and ventilation in one. So we're considering the Minotaur and the Chiltrix and a few others. And then down here are just some images of some of the control system we're looking at. And I think it's, yeah, so there's just a little bit more R&D that needs to be done on both the panels and the HVAC systems, but it's seeming promising that manufacturers from Europe and whatnot are feeling like there's a growing market in the United States to import these products and get them tested and certified in the state. And our demonstration sites, we're demonstrating on 300,000 square feet of low-income housing in disadvantaged communities in California. So we have 3 selected, and we're hoping to confirm our 4th, hopefully this week. So there's Veracruz Village, which is really the townhouse prototype here on the left, Murphy Ranch, which is in kind of the southern Bay Area, close to San Jose, more of a townhouse style, and then Beverly Terrace, which is in the northern Central Valley in Marysville. Also more of a townhouse style building. And then this Veracruz Village is next to Bakersfield, so hot southern Central Valley. And yeah, we're really excited to be testing out the panels and some of our transition technologies for HVAC, and hopefully we'll be able to use one of the European products on one of these projects. So yeah, I think that's it for me. Super excited to hear your guys' comments.